to be practice 3, number 3, using Ohm's law. And we're going to go ahead and write down all of our givens, which is current is equal to 4A, resistance is equal to 6 ohms. So this means that we are going to be looking for voltage. We are going to take our original equation of I is equal to V over R, and we're going to be isolating voltage. So we're going to multiply by R on both sides, and we have resistance times current is equal to voltage. Now, if you did some research on what the Ohm's law lab is, or what the Ohm's law equation is, it's probably going to look more like voltage is equal to current times resistance. So this is the equation that we want to use when solving for voltage. So we have voltage is equal to I times R. Voltage is equal to 4 amps times 6 ohms. We're going to have a voltage of 24 volts. Now, for our proportional reasoning, we're going to keep the same battery. We're looking for the current, and decreases to 3 ohms. So we started with 6 ohms, then it goes down to 3 ohms. So that means we're multiplying by 1/2. So we're going to half our resistance. We're going to keep the same battery. That means 1 over 1/2 is going to give us 2. So our current will be twice as much. Current is originally 4 amps, and 2 times 4 amps is going to give us 8 amps. And so our written description is keeping the voltage the same, the current will double if the resistance decreases by half. And let's go ahead and write why it does that. So, like in our lab, we had our graph of resistance versus current, and we had this shape going. And from our whiteboard discussions, this is called an inverse relationship. And K, the constant, now it's not the slope, but it's how it goes down constantly. K represented the voltage. So we have current or resistance current are inversely related. And so why that is because as resistance increases, what that's doing is charge flow is hindered or decreased. So that means that the current has to slow down because there's hindrance, or the charge flow is being slowed down, I guess, a little bit. Okay, but remember, we're not using the word slowed down. We're going to use it in terms of increase and decrease. So that would be an inverse.